Modern cars have brakes on all four wheels, operated by a hydraulic system. The brakes may be disc type or drum type. The front brakes play a greater part in stopping the car than the rear ones, because braking throws the car's weight forward onto the front wheels. Many cars therefore have disc brakes, which are generally more efficient, at the front and drum brakes at the rear. All disc braking systems are used on some expensive or high-performance cars, and all drum systems on some older or smaller cars. Brake hydraulics. A hydraulic brake circuit has fluid-filled master and slave cylinders connected by pipes. When you push the brake pedal, it depresses a piston in the master cylinder, forcing fluid along the pipe. The fluid travels to slave cylinders at each wheel and fills them, forcing pistons out to apply the brakes. Fluid pressure distributes itself evenly around the system. The combined surface pushing area of all the slave pistons is much greater than that of the piston in the master cylinder. Consequently, the master piston has to travel several inches to move the slave pistons the fraction of an inch it takes to apply the brakes. This arrangement allows a large force to be exerted by the brakes, in the same way that a long-handled lever can easily lift a heavy object a short distance. Most modern cars are fitted with two twin hydraulic circuits, with two master cylinders in tandem, in case one should fail. Sometimes one circuit works on the front brakes and one on the rear brakes, or each circuit works both front and rear brakes, or one of the four brakes works on the other circuit than the front ones. Under heavy braking, so much weight may come off the rear wheels that they lock, possibly causing a dangerous skid. For this reason, the rear brakes are deliberately made less powerful than the front. Most cars now also have a load-sensitive pressure-limiting valve. It closes when heavy braking raises hydraulic pressure to a level that might cause the rear brakes to lock, and prevents any further movement of fluid to them. Advanced cars may even have computer-controlled anti-lock systems that sense in various ways how the car is decelerating and whether any wheels are locking. Such systems apply and release the brakes in rapid succession to stop them locking. Power-assisted brakes. Many cars also have power assistance to reduce the effort needed to apply the brakes. Usually, the source of power is the pressure difference between the partial vacuum in the inlet manifold and the outside air. The servo unit that provides the assistance has a pipe connection to the inlet manifold. A direct-acting servo is fitted between the brake pedal and the master cylinder. The brake pedal pushes a rod that in turn pushes the master cylinder piston. But the brake pedal also works on a set of air valves, and there is a large rubber diaphragm connected to the master cylinder piston. When the brakes are off, both sides of the diaphragm are exposed to the vacuum from the manifold. Pressing the brake pedal closes the valve linking the rear side of the diaphragm to the manifold, and opens a valve that lets in air from outside. The higher pressure of the outside air forces the diaphragm forward to push on the master cylinder piston, and thereby assists the braking effort. If the pedal is then held, and pressure rises no further, the air valve admits no more air from outside, so the pressure on the brakes remains the same. When the pedal is released, space behind the diaphragm is reopened to the manifold, so the pressure drops and the diaphragm moves back. If the vacuum fails because the engine stops, for example, the brakes still work because there is a normal mechanical link between the pedal and the master cylinder. But much more force must be exerted on the brake pedal to apply them. Some cars have an indirect acting servo fitted in the hydrauli.